above the mouth of the Catatumbo River, where it empties into Lake Maracaibo in northwestern Venezuela. Lightning happens roughly 140 to 160 nights of the year. On the most active nights, witnesses count strikes at rates of 280 per hour. The lightning has been doing this in roughly the same patch of sky for at least 500 years. Spanish records from the colonial period mention it. The earliest published reference is in the 17th century epic poem La Dragonnetière by Lope de Vega, written in 1597, which describes Sir Francis Drake's 1955 attempted attack on the city of Maracaibo as having been visible to the Spanish defenders by lightning above the lake. Drake's ships, on the standard reading, were spotted because the storm was lighting them. Spanish-speaking sailors of the period had a name for the phenomenon: El Faro de Maracaibo, the Lighthouse of Maracaibo. It was visible from far out at sea. It was used as a navigational reference. It was, on the period evidence, predictable enough to plan around. Lake Maracaibo sits in a basin in northwestern Venezuela, ringed on three sides by mountains. To the south are the Andes. To the west is the Sierra de Perijá. To the north, the lake opens to the Caribbean. Warm, moist air rolls in off the Caribbean. The mountain walls force that air upward as it converges over the lake. At night, cooler air drains off the surrounding slopes and meets the rising warm air over a particular zone, the mouth of the Catatumbo River, where it empties into the lake's southwestern corner. What this produces, almost every night, is a stack of unstable atmosphere: warm wet air below, colder dry air above, with strong vertical mixing in a confined geographic space. It is the same recipe that produces thunderstorms anywhere on Earth, except that the geography here produces it consistently, in roughly the same spot, almost every night. The result is a single recurring nocturnal thunderstorm, fixed in place, that runs for about 10 hours and then ends. The figures most often cited come from a combination of NASA lightning imaging sensor satellite data, ground campaigns by Venezuelan meteorologists, and the Guinness World Records assessment that named Catatumbo the place on Earth with the highest concentration of lightning. In 2014, the numbers are striking. The storm occurs on between 140 and 160 nights per year. The active hours per night are roughly 9. The peak strike rate, on the most active nights, is around 280 cloud-to-ground and intra-cloud strikes per hour. The annual total over the affected zone is on the order of 250 strikes per square kilometer per year, the highest concentration measured anywhere. The strikes are mostly intracloud, bright, repeated, and silent at distance. The thunder, for observers on the lakeshore, is often inaudible. The lightning is constant and the night above the river mouth is, in effect, lit. Sound travels through air at roughly 340 meters per second. Light travels effectively instantly. A bolt of lightning 10 kilometers away produces thunder that arrives roughly 30 seconds later, attenuated. A bolt of lightning 20 kilometers away produces thunder that arrives a full minute later, much fainter. By 40 kilometers, the thunder is generally below the ambient sound floor. The Catatumbo storm is, for most settled towns around Lake Maracaibo, between 30 and 70 kilometers away. The lightning is visible. The thunder, by the time it reaches the population centers, is below the level of the night air, so what residents see, on most nights, is a flickering glow on a distant horizon, in silence. This is what made it a navigational landmark instead of a hazard. Sailors at sea could see the glow without hearing it and read the position of the lake from it. Yes, in 2010, the Catatumbo storm went silent. For approximately 6 weeks in late January, February, and early March, the lightning did not appear. Local fishermen and meteorologists noticed the absence immediately. The likely cause, on the meteorological reconstruction was an unusually severe regional drought tied to El Niño that disrupted the moisture flow off the Caribbean. The atmospheric stack that the storm needs simply did not assemble. When the rains returned in spring, the lightning returned with them. The episode is unusual in the historical record but not unique. The storm appears to be tied to specific regional moisture conditions and can be suppressed when those conditions break. Catatumbo is the largest single source of natural ozone in the upper troposphere over land in the tropics. Lightning splits atmospheric nitrogen and oxygen molecules. The resulting reactions produce nitrogen oxides and ozone. The persistent storm at the mouth of the Catatumbo River produces an outsized fraction of the regional atmospheric ozone budget, a fact established through atmospheric chemistry modeling and confirmed by satellite measurements. The methane explanation, that the storm is fueled by methane seeping from the wetlands and from the petroleum reservoirs beneath Lake Maracaibo, has appeared in popular sources for decades. The published atmospheric chemistry literature does not support this. The methane levels in the affected airspace are not anomalous. The storm appears to be entirely meteorological, not chemical. Above the mouth of one river in Venezuela, lightning happens almost every night. It happened in the 1590s, when Spanish poets wrote it down. It happens now. It is fixed in place by the geography of the basin around it, and it is silent at distance because of the basin's size. Most weather is local in space and brief in time. The Catatumbo storm is local in space and almost permanent in time. It is, in that sense, less a series of storms than a single recurring one. The lighthouse on the lake was never built. It is just the sky.